let's try to say create a database. Then let's try to create a table there, and let's see how it works. So to start Hive, you just need to have to write Hive once everything is set up there, and you just need to create database. It has created database. It is important that you write don't forget the command use here, because otherwise if you have just one database, then it is not really important, but make it a practice because there will be multiple databases in Hive. Okay, then to create a table, you just need to write create table. Okay, a few things here. Let me just run it once and then I'll show you what are the different things here. Okay, so basically what we're doing here is very simple. Create table. Name of the table is this. This table will be created in the database Edureka 1, and you're defining different fields in this table, okay, which are int, string, int, double, row format, delimited fields terminated by comma, stored as text file. Okay, and then what you do is you do a describe of this. Sorry. It will tell you, okay, this is the, when you do a describe, it will show you the schema of this, right? So these are the things which are there. Okay. Now let's try to run something here. Then what you do is, next thing is you will actually load the data into this table. Okay. So what are we doing here? Load data local in path. Okay. From this particular place into the transaction records. We'll look at that file also, and then we'll see what is happening here. Okay, it says copying data, copying file, loading data into table. It has not run any MapReduce till now. Okay. Now let's do. So this is the place. This directory basically is your warehouse directory where all the data will be stored if it is a managed table. I'll tell you the difference between managed table and external table as well. But if it is a table, let's assume if it is a table, all the data will be stored here. Okay, if you look at this, this is the Edureka 1 DB in which there's this directory which has this file. So when I moved it, it has got this file here. Okay, is it clear to everyone, guys? So now the file has been created, has been moved into this. Okay, so it's like we have not created in an internal database format. It looks like in the database Edureka 1, there's a table called transaction records where you have these. This is the file which you moved, right? Okay, is that clear to everyone, guys? So it's as simple as this. So, and then you do a select count star from transaction records. Let's see what happens now. Okay, now if you see, it has started running MapReduce, right? So basically whatever you do on Hive will be converted into MapReduce, similar to what was happening in Pig as well. And it says that okay, it took so much time. Okay, so this is, and this is these are the number of records which it has returned after that query. Okay, so clear with everyone. This is the time which it took. Okay, and this is where it created a MapReduce job. Okay, so it is as simple as that. Now this is how you can create a table. The table gets stored into the data warehouse. Okay, by default, if it is not a table, if it is not a external table, it will get stored there. Okay, and this is how you will be loading the data from, say, local path to this. Okay. Now let's try to see what is the external table. Now there is a concept which is called external table. External table is basically a table which is not, you don't move the data, okay, you let the data be there in the warehouse directory, in the SDFS itself, instead of moving that data in the warehouse directory. Okay, this table is not managed by Hive. Okay, the table will still remain there, the actual data will still remain there, only the metadata. Okay, yes, the loading can be done from local as well as from HDFS. That's right. So the data can be loaded in that managed table also from any of those. Now, but in an external table, the concept is that instead of moving the data into the data warehouse Hive, you will let the data remain at HDFS only, and you will just create a reference of that table. Okay, here, where you will just the metadata of this table will be stored in the meta store. Okay, so you will not be moving that table here, you will not be moving that data here. Usually when the data is large, and also the fact that when the data is being updated by multiple places, when the data is being used by multiple sources, we will be using the concept of external table. Okay, though it's just a user preference, most of the time people will be using managed tables. Sometimes you will be using a mix of those. I mean, obviously you will not be using everything in the external table. See, the thing is that when you get the data and you have to do a lot of analysis on that data and fast reporting on that data, it is better to use managed table. Okay, you can understand that because you don't have to all the time, you don't have to write all the queries on HDFS. The queries will then be written on the warehouse itself, inside the warehouse itself. At times there will be tables which will be used, which will be large, and which will be where the data, the amount of reporting you have to do is not much, but the amount of data change is huge, and there are multiple people who are using that same table. Okay, then you will not probably create a managed table, you will use an external table there, where the data still resides inside the the data keeps residing in the HDFS. You're not moving the data from HDFS to the warehouse, you're just writing the queries directly. Okay, now obviously when it comes to deleting a table, external table, when it is dropped, the table will not be Hive will not delete the external table because it is not inside it. Okay, the table is on HDFS, you will not be, the data is on HDFS, you will not be doing that, just the metadata will be deleted. Okay, is that clear to everyone, guys? Does that make sense? Can we quickly look at an example of external table? Only the schema is deleted, that's right. External tables will be used where you have large data and there are multiple sources, there are multiple people who will be looking at that data, and they'll be analyzing that. Okay, you'll not be generating huge amount of reports which will very frequently on that same data, but the fact is that the data gets refreshed a lot and the data size is very large. Okay, there you'll use an external table. So external table will reside on the HDFS only, you will not move it. Okay, external tables schema will be defined by Hive, and that will be stored in Metastore. Okay, let's look at an example. Let's look at how to create an external table. Okay, now in this case you have to specify a location where the external table will be. So in this case, is defined it as a root, not really on the HDFS, but so okay. So in this case, what we have done is that let's run it and let's see if it table is getting created. Then let's let's look at what is this common directory. So basically this is the place where your actual data in HDFS is stored. Okay, this is a location on the warehouse directory is also located on the HDFS. Well, Rakesh has a question, but I think users should be able to work on tables stored in where. Yes, Rakesh, that's right. So it's not only about users. There can be multiple users which can be connected. There can be multiple Hive instances which can be connected, and on the warehouse itself, multiple users can be used. But if the size is large, and if the cost of moving that data is more, then the kind of, if you don't have to do a lot of repetitive analysis on that data, then you'll probably use the external table. Okay, let's look at what is. So this is where the actual data is stored on the HDFS. Okay, and we've just given the location of that data. Okay, in this case, when I say external transaction records, okay, the location is common. Okay, and that's where we get that data. Okay, so yeah, what I was trying to show you is that this data now is on HDFS. If you look at here, this data is on HDFS. Okay, so if you look at this data is now on HDFS. Okay, we have not moved that data into the warehouse. Okay, is that clear? You still can do querying on this. Let's see if we can do some similar query on this. Okay, so in this case what we see here is that though the data was not there in the warehouse, we could still do a query on that data using an external table. Is that clear? Guys, is that clear how we can use the external table, how to create an external table, how to do a query from external table? Good, thank you, very nice. So okay, now let's move on. Let's see what is there in store. We're almost there on the time. Yeah, we've already seen this data loading. So load data into table. This is how you load data into the table from a local in path. Then you describe the transactions, and the describe, if you do a describe, you'll see the schema of the table. Okay, now these are the different type of queries. I mean, I'm sure everyone knows these queries. Select count star we just did, then select count distinct category from, so this shows you the distinct columns or the distinct categories from there. Okay, and you count the you do aggregation there. Then there is a grouping kind of thing, group by category. You will select category, some amount from this, and group by category. So these are the different type of queries which can be run here. Okay, if you want I can run them. A very important thing which is supported in this is inserting output into another table. Okay, so insert override table results from select star from transaction. So use select star from a table and insert into a different table. Similarly, you can do an insert of whatever is the result into a directory as well. Okay, so you can actually take the transactions and you put it into a temporary local directory as well. So that's also supported here. Okay, in the outputs, you can use the output of one table and put it in another output or another table, or you can even move it into a local directory.